Welcome to the New Jersey Institute of Technology website and math podcast. My name is Vanessa. Today I will be covering inequalities. Now obviously we all know that numbers differ in size. We have some that are smaller than others, some that are bigger than others, etc. And then once we can find those out by obviously plotting them on a number line or a number graph. But then once we figure that out, there's got to be an algebraic way to express it. And the way that we do express this is by using what's called inequalities. Now, once again, let's just take our variables A and B. They could be, like I said, they could be numbers, expressions, anything. Now, we want to express that A is equal to B. We already know how to do that. We just simply put an equal sign in there. But say we wanted to say something else, like A is less than B. That requires something else. It requires what's called an inequality sign. Now the way that we express that A is less than B is by simply putting a caret head, as they call it, the symbol. Now, for example, if we want to say the opposite, let's say we want to say A is greater than B, we simply take our little symbol and we flip it around this way. So let's just go over that one more time. Now generally, the way that I remember it is that, remember that the tip of the caret head faces whoever is smaller, and his head faces whoever is larger. So here we're saying that A is less than B, and here we're saying A is greater than B. These two are what's known as inequalities. Now, before we move on, I want to introduce you to a couple of properties, or rules as it can be thought of. One is called the trichotomy property. The trichotomy property has a scary name, but it's very simple. It just tells you that you have, when it comes to inequalities, you have three simple options. You have that A is less than B, you have that A is greater than B, or you can just still have A is equal to B. However, the trichotomy project tells you that out of these three options, only one can be true for your given inequality. You can't have more than one be true for anything. And the other property is called the transitive property. And this simply says, if A is less than B, and we're going to introduce now a new letter, and B is less than C, this simply means that A is less than C. Now you probably are asking, how did they get that? Well, if we were say to plot these on a number line, it might be easier to see. So let's see that. Let's get a number line. Alright, now it doesn't have to be exact, but it's just the thought process that is important. So let's take the first thing that they say. They say that A is less than B. So let's just plot. Now because A is less than B, that means A has to be to the left of B on a number line. It doesn't matter what the numbers are, but if A is less than B, it has to be towards the left of B. That's just the first condition. Now the second condition says that B is less than C. So that means that B has to be to the left of C. as this is. Now, basically what the property is telling you is that if A is less than B, as it is here, and B is less than C, A is less than C. And the number line shows it because A is to the left of C, which means that A is less than C. So the property makes complete sense. Alright? So one more time, the trichotomy property pretty much states that A can be less than B, A can be greater than B, or A can be equal to B, but it cannot be more than one option. And the transitive property pretty much says that if you have numbers on a number line such as this, and if A is less than B and B is less than C, then obviously A has to be less than C. So, let's do an example trying out our inequalities. Now, if you're not sure when you're given a certain question, like saying is one number less or greater than another number, and you're not sure, always if you're not sure, just draw a number line and it'll make your life so much easier. So, I'm going to give you 4 questions here, and you're going to tell me whether the statement is true or false. So, for part A, let me get that out of the way there. For part A, our first part is 5 is greater than 0. So pretty much they're just asking is 5, and because the caret head is facing the 0, that means they're asking is 5 greater than 0. Well, if you think to yourself on a number line, draw a quick number line. If 0 is here, and we just draw out our numbers, 1, 2, 3, 4, and 5, 0 is a lot more to the left than the number 5, therefore the answer is true. Okay, now let's try another one. Okay, let's try another one. -2 is less than -3. Okay, so let's just extend this line a little bit and draw out -2 and 3. So if we follow our number line, -1, -2, and -3. Okay, if we look here, -2 is to the right of -3. Therefore, -2 is actually greater than -3. This question here is asking, is -2 less than -3? That means the answer is no. So the statement is false. Okay? Let's try a couple more, just to make sure you get the hang of it. Okay, now let me just introduce to you a couple more inequality symbols that might prove useful. Now, sometimes when you have an expression or a few numbers, sometimes even though out of the 3 types of inequalities only one of them can be true, sometimes you're not sure which one it can be, and there's a possibility that it can be 2 out of the 3 inequalities. And there's a way of expressing that. And that's by saying that A is less than or equal to B, or A is greater than or equal to B. The line underneath the inequality sign implies equal or equal. So this would be less than or equal to. This implies greater than or equal to. So here you're saying that A can be less than or it can be equal to. On the second one that you're saying A can be greater than or it can be equal to. So here you're giving two possibilities. You're not saying that both are true. You're just saying one of the two can be true. And sometimes that happens when you're doing algebra. There's no straight answer when it comes to inequalities. Two possibilities can be true, and eventually you may have to prove which one is true. But let's move on from here. So let's check an example. What if we were to say let's try positive. Positive 2 is less than or equal to 3. Now let's look at our number line. 2 is to the left of 3. So what does that mean? That means 2 is less than 3. Here we're given two options. 2 is less than or equal to 3. So we're fulfilling this option on the top here. Therefore, the statement is still true. As long as it includes one of the possibilities is true, that means the whole statement is true. Okay? Let's try one more, and I think you'll have a good idea of how to do inequalities. What if we were to say 4 is less than or equal to 4? Now this we don't even need a number line for, because obviously 4 and 4 are the exact same number. So, but what is the inequality giving us? They're saying 4 is less than or equal to 4. Obviously 4 and 4 are equal, so we are fulfilling this possibility right here, still making the statement true. So once again, let's just do a quick little recap of everything that we've learned here today. There's different types of inequality statements you can make. You can say that A is less than B. You can say that A is greater than B. You can say that A is equal to B. And only one of these can be true, not more than one at the same time. However, sometimes you can include two possibilities in one statement by saying that A is less than or equal to B, or A is greater than or equal to B. And if at least one of these conditions apply, it still makes the whole statement true. Thank you for visiting the NJIT website. If you need further assistance, please stop by the Center for Academic and Professional Enrichment located in Kufrian Hall, room 200. Good luck with your studies.